Okay, so this is section B.2.2, which is more on curve fitting. So your classwork today is going to be questions 90 through 93, and then you will also be doing the math notes on negative and fractional exponents. So question 90 is going to ask you to find the equation of a line, but not in the way that you normally would. So normally we would actually find the slope and then from there find the y-intercept. But what they want you to do is to kind of create a system of equations. So for example, with the point 5 comma 15, that would be 15 equals 5m plus b. And then for 3 comma 7, it would be 7 equals 3m plus b. And then you have a system of two equations with two unknowns. And from there, you would solve for m and b. So the reason why they're doing that is to kind of lead you up to what we are going to do today. 91 is going to just be another practice, and then 92 is then going to apply that to exponential functions. So for 92, we're going to kind of do this one together. It says, can Mitchell's method from problem B/90 be used to find exponential functions that passes through 216 and 6,256? Consider this as you answer the questions below. So the first thing we want to do is write what the general formula is for an exponential function. So that's going to be y equals a times b to the x. The next question is asking us to use the 2 points that you know to create a system of equations. So basically, I'm going to plug in the 16 for y and the 2 for x, and then I'm going to do the same thing for 256 equals a times b to the 6th. And the last step is to solve both equations for a, and then set the equations equal to each other to solve your systems of equations for b. So we're going to go ahead and solve for a. To do that, I'm going to divide by b squared. So I get this, and then I have 256 divided by b to the 6th equals a. Now, since they're both equal to a, we could actually set them equal to each other. So you get 16 over b squared equals 256 over b to the 6th. And then we can do some cross multiplication. So you would have 16 b to the 6th equals 256 b squared. And you want to get your like terms on both sides. So I'm going to go ahead and divide by 16. So when I do that, I get b to the 6th. 256 divided by 16 is 16. And then I'm going to divide by b squared, and this is where you're going to use your exponent properties. So b to the 6th divided by b squared would be b to the 4th equals 16. And then lastly, you would want to undo raising something to the 4th power. So you'd take the 4th root. And so b equals 2. So now that we have b, we can then plug that in and solve for a. So we would do y equals, and then we have a times b to the x, but then we can plug in a point. So we know that 16 equals a times 2 squared. So 16 equals 4a. So a is just 4. So our final equation is y equals 4 times 2 to the x. So this way completely works every time. It just does get a little bit time consuming. So there is kind of a shortcut, which I wanted to show you. So the shortcut way would be to basically take your y values and divide them by each other. So again, this is another way. So I would take 256 and divide by 16. You're basically kind of just skipping steps. And you end up getting 16, okay? Then from there, we look at the 6 and the 2, and I'm going to do 6 minus 2, which is 4. And because the difference between those is 4, I'm going to take the 4th root of 16, which is then 2. So that's our b value. So now we have y equals a times 2 to the x. And then you can see that that's that same exact step up here. So basically what we did was we kind of cut out all of that stuff, and we have it just in this little step. So that's definitely an option. So what will happen after this problem is 93 is just going to have you do 2 more practice problems, and then you will continue with your math notes.